In question 1, we find the angle between the two vectors u vector and v vector. U vector is negative 2 comma 8 and v vector is 6 comma negative 2. So to determine the angle between two vectors, we use this formula, that is cosine theta. This equals the dot product of the two vectors, that is u dot v, and then this is divided by the product of their magnitudes, that is magnitude of u vector times the magnitude of v vector. So this is the formula that we utilize to determine the angle between the vectors u vector and v vector. So in the numerator, we have to determine the dot product of the two vectors, and in the denominator, we should find the product of the magnitudes of the two vectors. So let's do this here. We write cosine theta. This equals u vector is negative 2 comma 8. This one dot product with v vector, which is 6 comma negative 2, and then this is divided by the magnitude of u vector. We take the square root and the sum of the squares of the components. So it is negative 2 square plus 8 square. This is the magnitude of u vector, and then multiply this with the magnitude of v vector, which is the sum of the squares of the components. So it is 6 squared plus negative 2 square. Let's simplify this. In the numerator, we find the dot product. So when we do the dot product, we find the product of the corresponding components and sum them together. This one is negative 2 times 6 is negative 12. Then 8 times negative 2 is negative 16. So I write this as negative 16. And this is divided by the square root of negative 2 square is 4 and 8 square is 64. Is multiplied with 6 squared is 36 plus negative 2 square is 4. And so this gives negative 12, negative 16 is negative 28. And this is divided by 4 plus 64 is 68. This one is root 68. And then times 36 plus 4 is 40. So this one is square root of 40. So here we have cosine theta equals this result, that is negative 28 divided by root 68 times square root of 40. Therefore, we can determine theta by taking cosine inverse on both sides. So theta equals cosine inverse of this expression, that is negative 28 divided by square root of 68 times square root of 40. We plug this expression into the calculator. That is, we first determine this quotient and then take its cosine inverse and then approximate the given angle. And so we get 122.4 degrees. This is rounded to 10th of a degree. So this is the angle between the two vectors u vector and v vector. In question 2, we determine if the two vectors u vector and v vector are orthogonal or parallel. So here first let's do the dot product of these two vectors. That is, we do the dot product. That is u dot v, and this equals negative 2i plus j. This one dot with the v vector, replace v vector. And when we do the dot product, we multiply the corresponding components. That is negative 2 times the component of I is 1 here. So it is negative 2 times 1. And then add with the product of the j component. That is the j component here is 1 and the j component here is 2. So it is 1 times 2. And so this gives negative 2 times 1 is negative 2 plus 1 times 2 is 2, and negative 2 plus 2 equals 0. So here we get the dot product of the two vectors equals 0, and according to the dot product rules, If any two vectors their dot product is 0, then the two vectors are orthogonal to each other. So therefore we see that vectors v and u are orthogonal because the dot product is 0. In question 3, we determine the work done by the object when it is moved from the point 1, comma 3 to 5, comma 9 by the force vector 2, comma 3. So let's write the formula for work done, and this equals the dot product of the force vector with the displacement vector. So here F represents the force vector and D represents the displacement vector. Let's find the displacement vector. And for this, we consider the initial point, which is 1, comma 3, and the terminal point is 5, comma 9. And we do the difference from the terminal point with the initial point. That is, we take the x coordinate of the terminal point and then subtract 1 with the initial point. We do like this, that is x coordinate of the terminal point minus the x coordinate of the initial point, and this gives the x coordinate or the I component of the displacement vector. And then we take this 9, this is the y coordinate or the j component, and then the j component of this initial point. So we do the subtraction like this, that is 9 minus 3, and so this is the displacement vector. This equals 5 minus 1 is 4 and 9 minus 3 is 6. So we have determined the displacement vector d equals 4, comma 6. Therefore, we can find the work done using the formula. We can substitute into this formula. Let's replace force vector, which is 2, comma 3. So this has to be dot product with the displacement vector, which is 4, comma 6. And so when we do the dot product, we find the sum of the corresponding products, components products. That is 2 times 4 is 8, plus 3 times 6 is 18, and 8 plus 18 is 26, and the unit of this is foot pounds. So we put foot pounds, and this is the work done by the object.